Direct variation, you are going to write, so we did y equals mx plus b. This is easier than that. These are direct y equals kx. That's going to be what your equations look like, y equals kx. Now, when you're in science and you've got x and y, and you're like recording data on a graph or a chart, the x's usually stand for like time. That's usually, I can't think of anything else. It's time. You can't control x. X is happening whether you like it or not. Y is happening based on the x. So if it's been 1 minute, this is how far I can go. If it's been 10 minutes, this is how far I can go. If I have a water spigot spout turned on, the time that the water is running would be x, and how much water came out of the spout would be y. I wouldn't measure spout and then the time that took. That's kind of a backwards way of thinking. Okay, so you've got x and y. We've already talked about k. K is our COP, which stood for constant of proportionality. So that was K. Does anybody remember how we found K? Yes. Yep. Which is y's divided by x's. We called, well, we haven't yet, we're going to now. This constant of proportionality, we did a different way even further back when each thing cost the same amount. What is that? Yep. So this is just another way of saying unit rate. We've now made it a little more complicated and we call it slope. So this, since this is constant of proportionality, this is going to represent a proportional relationship. So everything, well, you're going to be doing the 8th grade version of is it proportional, is it not? Instead of saying proportional, you're going to say it's a direct variation. So this just means the same thing. I don't know why we have to call the same thing 15 different other things, but hey, guess what? There's one more way we can say this. Since we're talking direct variations, we had constant of proportionality in 7th grade when we called these proportions. Now that we're calling them direct variations, we can call it the constant of variation. Constant of variation. All of this means the same thing. These are all just different words that all mean, bless you, yeah. All right, now, we know that with proportional, since we made our T-chart about proportion, non-proportion, proportional relationships have one step. It's one set of multiplying. Let's do a harder one. And by harder, it's not hard. All right, so let's say this is, don't forget, y divided by x. That's what that means. So if I have the table, I'm going to pick one that's a little harder so that you see why you have to actually do it. 4, 12, 36, and 60. 0.29, 0.87, 2.61, and 4.35. X's are always on top, Y's are always on bottom. Somebody last class said, well, what if they're not? Well, then it's a mistake. Because sincerely, X's are on top, Y's are on bottom. If For some reason they're not. The person who made that chart did it wrong. Now, your goal is to decide, is this a direct variation or not? And I'm going to do a better job of explaining this than I did second period. I could say you really kind of need to check each one. Because if one is off, they're all wrong. So you need to find K. We're going to say calculate. Calculate K by dividing. You can do 1x, or it's y divided by x. Why did I write it that way? I don't know. Y divided by x. So pick a y. Any of those y's. 0.87. Okay. We're going to pick this one. And then this one. So we're going to go those two. So we're going to do 0.80. That's not an 8. 87 divided by 12. Y goes in the house. X goes outside. Decimal goes straight up. How many times can 12 go into 87? 7. What's 7 times 12? 84. That's 3. Bring down a 0. Can 12 go into 30? How many times? Twice. That's 24. Subtract. That's 6. Bring down a 0. How many times can it go into 60? 5, and now I'm done. The end. This is K. Now, this rule says that now I can multiply every x times K, and I should get this as Y. In the event that you are given a situation where you have to decide if it is proportional direct variation, you really kind of need to check them all. I hate to say that because it's a lot of work, but you really do. Because if one of these doesn't work, then the whole thing isn't a direct variation because that would cause a bend in the line. So we're going to check each one. Now this is where you get a choice. You can either divide if you rather divide. You can divide these two, divide these two, divide these two. Or just multiply by 0.0725. So if you prefer multiplication, multiply by 0.0725. If you prefer division, divide y by x. 4 times 0.0725, 36 times 0.0725, 60 times 0.0725. You should get 0.29, 2.61, 4.35. So I'm going to do 0.0725. I'm going to do times a 4 just to show. So that's 20, 10, 29, 2, 1, 2, 3, 4, 0.29. So that checks out. That's a good one. Now I could divide these. 36 divided by, nope, y goes in the house. Ignore this. Sorry, y goes in the house. 2.61 divided by 36. That'd be 0. Oh, I lost my train of thought. This should be 7. So that's going to be 42, 25, 6, 5, 11 to 9. Bring down a 0. I'm going to guess it's a 2. That's going to be 72. 18. Bring down to 0. It helps when you know what you're shooting for. 5. Because it should, so 0.075, that's K. So that matches up. So that's good. This one checks out. This one checks out. Multiplying seems easier to me, but that's a personal preference. So 0.0725 times 60. Hang off that 0 so I don't have to mess with it. Oh, thank you. 12, 15, 45, 4, 1, 2, 3, 4, 4.5. Oh, wait, what did I mess up? Oh, that should be 43. 42, 43, then 4. So 4.35. So they all check. So this is a direct variation. And that's pretty much